In 1967, Jimi Hendrix took the stage as the opening act for the Monkees. In 1981, warming up the audience for the Rolling Stones was a future headliner, Prince. You're not sensing a theme here? In 1974, Queen opened for everybody's favorite, Mott the Hoople.
Can you go closer to the microphone?
Try. There we go. So Queen opened for Mott the Hoople. More recently, Pussycats were featured performer, and the opening act was Lady Gaga. Preceding Rascal Flatts on stage was Taylor Swift. Doesn't always work out like these examples, but it happens. I'm not suggesting that I'm going to win a Nobel Prize, but you never know. Well, sometimes actually, in this case, you do really know, but whatever. We have some guests today. Who's going to introduce Linda Butler today?
Bill Bowen. Where's Bill? He's not here.
Okay, Cliff, you're going to have to do it yourself.
This is Linda.
Darren Simkin is a neighbor and a dermatologist. There's no connection really there. But he's here as our guest today and may be interested in joining the club, seeing how things work.
Anyone else? No. Yes.
Neil Sid, I'm a neighbor of Eric Gilbert. Talked a bunch to Christian as well, and this is my third luncheon, so hopefully we're going to get a button soon.
No one guests? How about visiting Rotarians? No? Let me start the fine basket. My dollars are already in there because I have not won a Nobel Prize. Anyone else who has, at least put in a dollar. Our club is very fortunate to have a good number of new members in the past year. I'd like to personally welcome all of you. As you can see from our hometown radio station, I see sitting back there, WCHL, Aubrey and Aaron. Just so you know, you both passed the minimum length of membership requirement before you can be heckled. And for as long as I remember, and believe it or not, that was passed this morning's breakfast, WCHL has always been our community's primary provider of local news, which is why I was shocked when they just had recognized Christy Jones as their hometown hero. I mean, we've all known her the hometown hero for years, right? Okay, so I'm pretty certain only one person in the room can claim to have won a Nobel Prize. Actually, looking around this room, probably more of you can might claim it, but only one can actually say it truthfully. But that doesn't mean that each of you doesn't have some one defining thing you can say about yourselves that sets you apart from others. Think for a moment what that might be. For me, the answer is easy. Unfortunately, I peaked at an early age. My defining moment came a couple of months before I turned 18, during spring break of my freshman year at Carolina. I was on a flight supposedly headed to Miami, it was waylaid by 3 hijackers to Havana. Not by choice, I spent 24 hours in Cuba. I don't have time to share the entire story with you, but something that I vividly remember is being close to know with Fuller. A bunch of soldiers holding rifles with bayonets affixed to them and pointing them at our stomachs. That was not a warm and fuzzy greeting. But eventually we found out that we would be flown to Miami. The plane that we were on was too large for the runway, actually, in Havana. It was one of the worst landings I've ever had. And it couldn't take off from there with the weighted passengers. So at some point, the crew abandoned us, and they flew back to Miami. And we're sitting in the airport in Havana still. After it got pitch black out, we were bussed across the island to Veradero Beach Hotel, which I guess at one point had been a luxury hotel. By our standards, not so much anymore. But the good thing was, when we arrived there about 2 a.m., the bar was open and everything was on the house. The Eastern Airlines would ultimately be forced to pay the bill. And the amount of drinking done by the passengers is not what led to the demise of Eastern Airlines. We might have sped it up. So before turning it over to President Felix, our international man of intrigue, I want to congratulate Dr. Sancar on his remarkable work. Thank you for building this beautiful center and hosting our club's meetings. And although I don't expect any problems from our president, please be careful. There is now a precedent for presidents to try and snitch Nobel Prizes from the award winners.
Thank you, Steve. Good afternoon, Rotarians. Before I make a few announcements, I have some very good news, and this is initiatives that Liz Hankey and Christy Jones, with their creative minds, put together. And I would like Christy Jones, our hometown hero, to share the news with us. Yes.
Well, this is mostly Liz Hinkie. As you know, she is just the guru of solar energy. She's been working with a group called Solar Equity, which was started by a former intern of hers. And Solar Equity has many endeavors, but the one that we are most interested in right now is they are proposing to add solar array and storage batteries to a community center called the Big Ivy Community Center in western North Carolina. It's sort of been a hub for people after Hurricane Helene, and they want to be able to become more resilient so that in the future, such things like this, they can store all the food for people, people can come charge. It will just be a place that the community can continue to come to. So Liz brought to, I'm part of a Western North Carolina recovery and relief group with our Rotary district. So Liz brought that proposal to us. Our district committed $10,000 to it. The district where Bernardsville, that's the town this will take place in, they committed $10,000. And then all I did, I just shepherded it through the grant process. And so we took it to the zone, asked for a grant, we got $25,000 from them also. So we are contributing $45,000 to this initiative, which is the total project's like about $140,000, but they have got most of the rest of it in place and are going to get going on pretty soon. So. And there will be an opportunity and a need for some of us to go when it's all ready. We're going to have like a a barn raising, except we're gonna be solar panel raising. So, watch out for that in the months to come. Thanks.
Rotarians, give it up to our hometown hero, to our leadership, and what he does for our community. Hey, what a day last Friday. Valentine's extravaganza. That was awesome. Thank you to Alan Young, Randy, Bill Boyne, Mr. Carter, our performers, and all of you that showed up to make that event a success and memorable. Quick reminder, we have the blood drive on March 4th, so please continue to sign up. We have the community trash collection, March 7th. Vince shared an email, I don't know that Vince is here today, but yeah, shared an email. Please continue to sign up. We want to help clean and care for our community. And we are honored today, as you know, we have a very special guest, Dr. Aziz Sancar, and I'd like to invite Fezzi to come take the mic and introduce our guest. Oh, I forgot something. Sorry about that. Peggy.
Yeah, just quick, some of you wanted t-shirts but didn't go in on the first order. We have 7 extra. So if you want to buy a t-shirt, they're $20, and there's 8 people who haven't picked them up. So, meet me out there afterwards. No, it's going to be because I'm a regular reporter.
I guess you guys didn't know my real name is Aziz Sancar. This whole time. Well, thank you for coming today. We appreciate your presence. Yes, we do have Dr. Sancar here today. He's a namesake of our foundation with his wife. And as everybody knows, actually, I'm going to show a brief video on his biography first. So you will know more than what I can tell you. And then you will have a presentation on his most recent work, specifically on brain tumor. And I couldn't go any further than that because my scientific knowledge doesn't express that far. All right, so we'll start with the quick video here.
Aziz Sancar from Turkey is the Turkish citizen.
Bunların hem insan olarak verdiği tatminlik var hem de bunun insanlığa faydalı olacağını biliyorsunuz. Onun hiçbir şey değil. Yani ben Nobel'e almasaydım bile oradaki tek gerçekten bir
13'te şu haritayı yaptık. 1981'de, 1992'de Aziz Sancar'da bunu keşfetti. Uzun çocuk bunu bildi. O önemli.
Aziz Sancar. He devoted his life to science, and he harmonized science into his life. His first award was from the contented parents of children he healed when he was a young doctor in Sancar, a small province of Mardin. His most significant prize has been the Nobel Prize from the King of Sweden for his discovery about the mechanisms of DNA repair and contribution to mankind when he was a senior scholar. Those were the happiest days of my life, was his quote for his years in Sancar as a young doctor. There is no fulfillment like saving the lives of others. After years of hard work and long hours in the laboratory, he was awarded the Nobel Prize. He says, that was one of the special days of my life. He was, of course, very happy to win the highest honor in science, but the main reason was because science was the headline for months in Turkey, and people were excited about it and inspired about scientific research, because it gave him the opportunity to encourage Turkish youth to do scientific research. Because this award also brings recognition to the University of North Carolina at Chapel Hill, which has supported his research for over 30 years. Aziz Sancar, born in Sancar, Mardin, as the son of Abdul Ghani and Miriam Sancar, a very crowded farmer's family. He finished his first and secondary schools in Sancar and graduated from high school in Mardin. What they were suffering was not really poverty, but in fact, some sort of deprivation. He was barefooted in summers until he was 14. He didn't have shoes, except for school days. He received his medical degree from Istanbul University and his PhD from the University of Texas at Dallas. He then worked and studied for 5 years at Yale University before becoming a member of the faculty at the University of North Carolina at Chapel Hill, trying to achieve always a bit more, always a bit more. His life is not only full of success with accomplishments and contributions in science, but also a long and tough journey full of adventures. At the age of 6, he started to enjoy the school life with the help of his illiterate parents and with the endless support of his brother, Ken. He calls him his idol who became a general in the years that followed. His teachers in Sancar schools were graduates of the village teachers' institutes established by the new republic. At the age of 11, he started discovering the secrets of nature. He allows ants to march on his body, examines miraculous changes of almond trees. He will go beyond the limits of imagination and test his patience, his determination. At the age of 15, he traveled to Mardin to continue his education. There, he loved to study French, and especially chemistry. Throughout his early life, he was a devoted student and soccer player. He dreamed of wearing the national team jersey and was even invited to try out for the under-18 Turkish national team. However, he realized that he had an even greater dream: to become a chemist and solve the mysteries of the human body. At 17, he became a hard-working medical student, and at 22, he became a doctor determined to pay his gratitude to his country, a healer with the slogan of free treatment. But always he wanted to understand why some medicines cured diseases, like tuberculosis, and others did not. At the age of 25, he came to the United States to study biochemistry and molecular biology. Sometimes discouraged, sometimes staying awake in the laboratory all night, but always showing patience and never losing his determination to understand the secrets of living organisms. At the age of 30, he fell in love with Gwen, a scholar like himself. They got married. A lifetime companionship will begin between the two, and Gwen will become a true Turkish lover. He would come home from his laboratory when he made his discovery that will lead him to the Nobel Prize, and would share his first excitement with his wife. Gwen, I made a very important discovery for mankind today. Only I and God know about it. At the age of 45, Aziz Sancar had made many important discoveries in the field of DNA repair. By the age of 55, many of his discoveries were included in science textbooks and science histories. By the age of 60, he received the Koch Award, which is the most prestigious science award of his country. Together with his prize money, his wife's support, and their personal savings, he established the Aziz and Gwen Sancar Foundation and Turkish House. The foundation offers housing and moral support to Turkish students studying in the USA. I suffered a lot when I first came to the USA. I don't want them to experience the same, he said. A second purpose of the foundation is to introduce Americans to Turkish culture and history. At the age of 69, he was awarded the Nobel Prize, like a reward offered to the life of science. At 70, he presented the Nobel medal to Anıtkabir, to his Atatürk, to Turkey, in a solemn ceremony acknowledging his great debt to the education system established by Atatürk.
Özellikle ben de Sayın Sancar'ı gerçekten bu Nobel Kimya Ödülü'nü silsilesiyle aslında bir yetim adına tekrar tebrik ediyorum. Ve bu madalyanın Ankara'da sergilenmesini de gençliğin için geleceğe yönelik bir işaret şeyi olarak görüyorum. Ve daha önce Nobel ödüllerini alma noktasında görüyorum ki bu adeta bir yol haritasını belirleme olacaktır. Çok çok teşekkür ediyorum. Sağlık, sıhhat, afiyetle geleceğinizin inşallah aydın olsun diliyorum.
Bu madalyayı buraya vermekle Atatürk'e ve Atatürk'ün ve arkadaşlarına, Türkiye Cumhuriyeti'nin kuranlara vefa borcumu
Aziz Sancar. Some walk endless under the stars. He spent long hours in his laboratory with endless patience and love. Some have dreams of holidays. He always dreamt of new discoveries for mankind. Most people carry the pictures of their loved ones in their wallets. He has the DNA repair one. He is a man of fidelity. He was always loyal to his family members back in Turkey during his 40 years in the USA.
Kardeşimin bu başarı kazanmasını ben hiç yadırgamış değilim. Dediğim gibi insanlara hizmet etmek gayreti içindedir. Hiçbir maddi düşüncesi asla yoktur aslında. Yani maddeyle hiçbir ilişkisi olmayan, zevkle, sefayla, eğlencesiyle ilişkisi olmayan, sadece insanlık için uluslar özellikle bu tür kanser ve onun gibi hastalıklarda bir çare bulmak için, bir çözüm bulmak için Tüm hayatını vakfetmiştir bu işe. Kendisi son derece mütevazi bir insan. Hiçbir kibir yoktur, bir gösterişi yoktur. Çok sade bir insan.
He also showed his gratitude to his professor Muzaffer Aksor, who opened up the doors of American universities for him. He often mentioned his name and visited him. He is also loyal to his American universities for offering him the opportunities of endless freedom and for sharing his enthusiasm for scientific discoveries. Aziz Sancar believes in the infinite potential of science for the betterment of mankind. He says, the world will never be a better place unless governments invest more in science than in defense. After receiving his Nobel Prize, President Obama invited him to the White House, and Sancar showed no reluctance to express his concern about the 20% budget cut for scientific research. Yes, the path leading to the Nobel Prize was rough, and it required great patience. Sancar, with a superhuman working pace, realized 6 very fundamental discoveries during his long life of research. Of those 6 discoveries, 5 are about DNA repair. Following an article about jet lag, during a long flight, he made a discovery about the proteins conducting the human biological clock. He is also an inspiration to other scientific researchers trying to find a cure for diseases like cancer. He is patriotic, has a deep love for Turkey. He describes his homesickness like this: the people of my homeland are very warm. I have never seen anything like it anywhere else. My eyes are filled with tears every time I visit Turkey. His heart is filled with Atatürk, but also he remembers the magical verses of Yunus Emre. He fulfills his longing for his country with the folk songs of Ruhi Su. He admires the perseverance and folk songs of Aşık Veysel.
Uzun ince bir yoldayım, gidiyorum gündüz gece.
Aziz Sancar has a generous heart. He used to distribute medication free of charge when he was a small-town doctor. He established a fund in the United States and provided a scholarship for the students of Sabur High School. This generosity shows in the establishment of the Turkish house in Chapel Hill. Sharing for all, giving to the people in need, devoting himself. Aziz Sancar has another dream. In order to reach more students, to render family warmth to each and every student, to celebrate Turkish culture, and to educate Americans about the history and culture of his homeland. He and Gwen have a dream of building a second, larger Turkish house. They hope to purchase the land before the end of this year and to begin construction as soon as possible. Aziz Sancar is humble. He has the soul of a dervish. He is our pride. This is why he is the face of shared love, common goals, and consciousness in our country, following his Nobel Prize. His statues were made, stamps were issued under his name. Many universities and schools in Turkey bear his name. But most importantly for Turkish students willing to follow a scientific path, He became an inspiration, a role model. So, what else do you need? May God bless your heart, Aziz Sancar.
Mezun olmaya gerek yok. Savur'dan, Sürgüt'ten, Türkiye'nin herhangi bir üniversitesinden, lisesinden mezun olup hem memlekete hem insanlığa önemli katkılar yapabilirsiniz. Bizim çocuklara güven vermemiz lazım. Yani bu çok önemli.
Thank you for watching this, and I'm touched. I mean, every time I watch this, I just gets emotional. But obviously, we accomplished some of the plans, and this center is built. And as you guys know, the scholars residence is at full swing up the hill. This is really Dr. Sancar's dream, and I am not going to pass this opportunity to tell about his experience when he went to University of Dallas. He got caught by campus security taking a shower with a fire hose in the lab. And when they said, "Who are you? What are you?" it turns out that nobody asked him if he had a place to stay. And that is Dr. Sancar's dream up the hill, that we'll have 8 rooms to be able to accommodate so they can focus on their studies while they're here. As he said, he doesn't want them to experience what he did. And one more thing, I don't know if anybody noticed it, but have you guys noticed the design on our chairs? So this place is such a big place. We have a lot of little things, a lot of little things that means a lot of different things and has a lot of deep meaning. And I'll get a chance, and of course, you mentioned the topic. This the picture of the topic is the founder of the modern Turkish Republic. So Dr. Sancar always said he is the product of his reforms. And he said that, Aziz Hoca, I'm going to invite him to give you a quick presentation on his recent work on the treatment of glioblastoma. I hope I didn't put you on. So we get the microphone. This is really cool. In the meantime, can I answer any questions related with this place? That's something I mean, don't ask me about DNA repair. It's beyond me.
Further. Further.
I have a question.
Go ahead.
How many Turkish students are at UNC?
Well, I couldn't tell, but we have several students at UNC, right? How many students we have at UNC? How many students do we have at UNC? Turkish students. Turkish students. How many Turkish students do we have at UNC? Yeah, but I know Dr. Aziz has several in his lab, and they do receive government scholarships to come and study. So it will not be a problem at all for us to give up the houses. That's what you're concerned about, because we already got people inquiring about can I come and stay there. So there's several of them are doing their PhDs or postdoctoral studies. We're not even talking about the undergraduates. And I can tell you this much, that when they're going to have a party here, the UNC Turkish Student Association, they're coming again. They fill this room up. They turn it into a disco. So I can tell you we have that many.
Okay, thank you very much. And do you hear me in the back?
Yes.
Okay. That was a very serious presentation, and I'll try to add some humor to it. So actually, I've written a book with the title "Science is a Contact Sport." And it is really contact sports, and you will see how. As was shown in the presentation, I worked on DNA repair, and I worked on the circadian clock, and I also work on the cell cycle, which regulates how cells grow in regulated manner and don't become carcinogenic. So I first started my career working on DNA repair. My PhD was at the University of Texas at Dallas. And my mentor was Stan Ruther. To this day, he been the best mentor I ever had, the best human being I ever encountered. He wasn't just a great mentor, but also a great human being. And for the rest of his life, I was a friend of his and his family. So after doing my PhD with him, I applied to other DNA repair labs that work on different aspects of DNA repair. And I got rejected from all of them. And I had a classmate who attended a recent scientific meeting. She said, there is this group at Yale trying to clone DNA repair data. Cloning was very recent, and actually it was illegal to do cloning because there was a concern about spreading cancer genes by cloning them and getting everybody infected, etc. So she said, and actually I didn't listen to that moratorium. I cloned the gene, and that's how I got my PhD. But, so the east of Stanford, the first gene was cloned in Texas by me, and but that's a different story. She said there is this group at Yale trying to clone genes like different types of repair, like you did with this gene, and see if they might be interested. And I applied and was accepted. And there I worked very hard on a particular form of DNA repair. It's called nucleotide excision repair. This repair system is found from bacteria all the way to humans, and what it does is it when we go into sunlight, sunlight causes damage to DNA, and there is an enzyme that cuts the damage and removes it, and then the DNA is the gap is filled in, and the DNA is back to normal. But how this happens, it was not known. And the phenomenon was discovered in 1964, and here I was in 1978. Still no one knew how it worked, and there were many labs working on it. And when I say many labs, 20 labs were working on it throughout the world, and I'll mention some of them. 2 labs at Stanford, 1 at Berkeley, 2 at Harvard, 1 at MIT, the chair of biochemistry at Johns Hopkins, of course Yale, where I was doing my postdoc. I was working on it, but across the town, a famous professor was also working on it. And in addition to these groups in the United States, there was a major group in the Netherlands, a group of 20 people, and they accomplished scientists in Norway and Japan working. So it was a crowded field when I entered it, and so I was young and ambitious, and I worked hard. I said I'll compete with all these people, and so I did, and in 1982 I finally figured it out, and that year my professor, Dean Rook at Yale, the person I worked for, I was a postdoc there, went to a meeting in Toulouse, France. I have the date here, May 1982, and he presented my findings, and I guess there are no pointers. Is there? Doesn't matter. A point to look up. Okay. Yeah. So.
Laser pointers do not show up on backlit screens.
That's right.
Okay, it's all right.
It absorbs.
That's okay.
Yep.
So it's going on. So my professor presented my result there, and our major competitor, the chair of Johns Hopkins biochemistry department, and said to the audience after he was a very extrovert person. Was a good person, but we all have personalities. This personality happened to be an extrovert and outspoken. When he showed them what I had found here, he raised his hand and he said, "It's not written on stone. It's not written in stone." And here you see it. This is harken back, you can see it, and it is written in stone. You see it. It is carved in stone. So it wasn't my most important contribution to science, but this was for whatever reason when the Nobel Committee decided to give a Nobel Prize for DNA repair. Among many other things I had done, they decided on the carved stone figure. And so this is their announcement on October 8, 2015. Now, if you compare here, so here's one cut, and that's the other cut. This is a cut in here and cut in here. This is the damage caused by the ultraviolet light. And so you get two cuts and you remove this fragment. And so you see, these are the units we call them bases. You see this, and where DNA has directionality. This is 5 prime, this is 3 prime. You count 1, 2, 3, 4, 5, 6, 7. 7 units, 5 prime, and 3 prime, and 2 damage total makes 13, 12. Okay, so 12 is removed. By coupling asymmetric fold. And I believe the Nobel Committee that decided to give Nobel for DNA repair was not that knowledgeable about the details of DNA repair. So when they made the announcement, see, this is the figure that they're showing. And do you notice the difference? They decided it should be symmetrical. 1, 2, 3, 4, 5 on the 5 prime, and 5 prime, 5 on the 6 prime. And you have the downward advance up to 12. It's the same number of units that are removed, but this is the wrong figure. And it stayed there because that's not what is written in stone. Later on, they corrected actually, and when they made posters, we have it at our university, we have it at 30 center. It's been corrected by the Nobel Committee to be like that and targets from so stand in the store to try to develop a method to treat glioblastoma. It is one of the worst types of cancers. The average survival rate, survival time from diagnosis is about 2 years. And there is really no treatment for it. There is one drug called temozolomide, and the standard cancer therapy methods, meaning radiation and surgery. So temozolomide drug, then radiation, then surgery, and that's the treatment. Temozolomide drug works in the beginning, then resistance develops, and radiation and surgery can't really take care of it, because in the brain you cannot do serious radiation or surgery, because the brain is very delicate organ. You're going to destroy the brain yourself. And for those reasons, like I said, the average survival, well, there is no survival really, lifespan after diagnosis 2 years. So, and in the last 5 years, we've been trying to develop a new method for treating glioblastoma. And what the new method is stated in the bottom. Surgery, this is the standard method. Surgery, ionization, temozolomide. Now, the new method we developed is using a chemical called EDU. EDU, the structure is shown here. This is a normal unit of DNA. And EDU stands for ethinyl deoxyuridine. So it is very similar to thymidine, one of the building blocks of DNA. It's very similar. If you look at this, the only difference here is you have CH3 here, you have a double bond there. That's the only difference.
Pretty subtle.
This was developed by Greek chemists for so-called click chemistry. I hope there are some of you who heard click chemistry. 3 scientists got the Nobel Prize actually for developing click chemistry, because this group here is very specific for clicking with another group, and so you have it in the cell, and you treat the cells with a chemical that has the complementary group, and that reacts only with that group here on EGU, and that way you can study DNA replication, DNA recombination, and DNA repair, and so on. And that's been, it is one of the most commonly used methods in molecular biology. And so if you look at our method, we ignore the Nobel version, let's do the Carden-Stone version. Okay, you remove the 12th nerve, but you make a gap in it. The DNA is a duplex. Now, when you remove 12, you have a gap here, you have to fill it. And there's an enzyme that fills it. But we wanted to ask this question, when it fills it, does it just fill it completely and then ligates it, just like ligate in normal life? Or does it proceed and make this fat, the fat from it? It was very simple question to ask, and I think it was a project for a new graduate student to teach molecular biology, because it's a simple concept. You have a gap, you fill it, whether it's just filling it or it is made a bit, the patch is a little bigger. So, I asked the postdoc to grow cells and put EDU and irradiate them and put EDU and see the incorporation between the stored. And as a control, you use cells that were irradiated, and of course then you will get excision. So the postdoc came and she said, when I irradiate cells and put EDUs, it is incorporated into that gap. But she said, in my X-ray film, I also see that cells that were not treated with DNA damage also had incorporated EDU. To make myself clear, so cells that are not irradiated, they're not replicating, you put EDU has no place to go. It's not supposed to incorporate into DNA, but when we test it, it is incorporated into DNA. And so at that point I said, well, repeat the experiment totally in dark, so there is no accidental DNA damage. She repeated, still same result. I said, okay, that EDU is incorporated into DNA, and when it's incorporated, the cell recognizes it as a damage and removes it. And the cells were dying, and it is removed, the cell, it is incorporated, the cell removes it, and then you're having the gap again, but then EDU gets reincorporated. The cell removes it, then it gets reincorporated. It creates vicious cycle. Eventually the cell dies. So seeing that, then I thought that perhaps we could use this in glioblastoma treatment. And the reason is many of the drugs, for example, cisplatin, you may have heard it, it's the most commonly used anti-cancer drug, but it does not, there is something called blood-brain barrier. It cannot cross it. And because of that, you cannot use it to treat brain cancer. But this EDU easily crosses blood-brain barrier and kills the cells that incorporates it. I said by doing that, we may be able to treat glioblastoma. And so, there are some facts about the glioblastoma. It is one of the most lethal cancers. Median survival is about 12 months, and standard of care is listed there, like I said, surgery ionizing radiation chromosome. So then we put human brain cancer in mouse brain, there's wave doing it, and then we treat them with EDU. And then here we're staying with EDU. You see the mouse, the human brain cancer growing in the mouse brain, and when we put EDU, we stem for EDU, it's incorporated only where the tumor is. And this is another example. And so, with that then, we said, what it killed the tumor and increased it much condition.
Okay.
And here you have mice without treatment, they die within 50 days. If we treat with temozolomide, they die. With high temozolomide also, they survive. When we treat with EDU, this is EDU, you see the survival is 50, and when we combine EDU and temozolomide, the mice survive.
Dr. Sancar.
Another demonstration for the duration of the experiment. The mice are filled with, and so our conclusion is that the treatment for glioblastoma should be EDU plus temozolomide plus necessary radiation. Unfortunately, EDU is not cheap. It is synthesized in India, and to use it in humans, we need about $2 million.
Dr. Sancar, on behalf of East Chapel Hill Rotary Club, we want to thank you for your scientific development that has transformed so many lives. And also we want to thank you and Gwen for letting us use this facility that is so beautiful, and we love it. We have a small token of appreciation, and I'll let Bobby Yusuf present his artwork to you. So, and it has a quote from the famous Rumi, flow down and down in always widening rings of being. And this is one more. Yeah. Thank you everybody for coming. Have a nice weekend.
Yeah, let me close that. Did you take a picture of me?